Good afternoon, ladies and gentlemen. It's a great honor and privilege to be here in front today. A great pleasure to present you my research on measurement and temperature of oxyhydrogen flame. My name is Slobodan Stankovic. I come from Switzerland, and I'm a free-time experimentalist, not like you. I'm doing this for 10 years now. So, this research is a part of a bigger project, which is the use of the oxyhydrogen gas issued from the water electrolysis. And it's not being used like a fuel, but as energy carrier. As you know, the oxyhydrogen gas, also known as HHO or brown gas, is very popular among experimentalists because of the ability to easily build a setup for its production and to use it readily for certain experiments. But beyond that, there are very few in-depth studies or analysis of its strange behavior and its extraordinary properties. As such, I began my own research by reading specialized literature and conducting a lot of experiments by myself. By measuring the measurement of the oxyhydrogen gas temperature was the first step trying to explain some of the facts. One of them is that oxyhydrogen can melt metals like tungsten at a temperature of around 3,500 degrees C. But to measure its real temperature, of the oxyhydrogen gas, I need a non-chosen method. And I found one particular article authored by 3 Iranian scientists who did perform a laser reflectometry on the electric arc in order to determine its temperature and electron density. I therefore started to put the experiment in place and to adapt it to my own needs. Reflectometry is a method of wavefront analysis and in which both the tablet effect and more fringe analysis are applied, and in my case, they're applied in a phase object. On this slide, you can see the experimental setup where the light beam passes through the plasma medium and rocky grattings, and it's deflected due to the refractive index gradient. What was first calculated was the deflection angle, and with that angle for each point of the plasma was calculated with inverse Abel integral the refractive index of the plasma medium. The refractive index of the plasma as an ionized gas includes a contribution of neutron molecules, ions, and electrons, and for the low temperature plasma, which is the case in my experiment, only the first ionization considered to be the calculation of the electron density curve. Considering the close relationship between the refractive index and plasma temperature, it's now possible to estimate the temperature of the flame by placing the refractive index of the oxyhydrogen plasma on its electron density curve. And with this method, I discovered the temperature of the oxyhydrogen flame varies between 130 and 150 degrees C. The next research, which is underway, will be radiation measurement of the interaction of the oxyhydrogen plasma with different elements with my 3D array gamma ray scintillator, but this will be, I hope, presented in the next year conference. Thank you for listening.
Thank you.